Hello everyone, welcome once again to my YouTube channel. Today we're looking at 3D array manipulation in NumPy. Now while we're looking at this topic, it's very important, it's a foundational topic for deep learning, and we need to understand how three-dimensional arrays are being manipulated because every data you are going to be using in your deep learning framework must be put in three-dimensional array format. So sit back, relax, and enjoy the teaching. Okay, so to manipulate a three-dimensional array, we are using the NumPy library. Take notes, in machine learning, we use NumPy library very well. Why? Because your data sets are usually in numbers, and the NumPy library manipulates numbers very fast and effectively. You don't need to start using for loop. Everything already inbuilt into the NumPy library, and it loops through numbers very fast. So now we import our NumPy as NP. So now for our explanation today, we're creating an array with 3 tables, 2 rows, and 5 columns. So, well, my aim is to make the explanation as understandable as possible. So I decided to use the word table for the first element. But in reality, what is usually called is depth. So we call it 3 depths, 2 row, and 5 columns. Now, it depends on what you are referencing. For me, for example, if you are referencing a 3D image, for example, you'll be looking at the depth, how thick, the thickness of the image. For example, if you are dealing with a square, it's just two-sided row and column you are dealing with. But if you are dealing with a box, now all boxes are not the same sizes. So some boxes are thicker than others. That is, they have more space inside, while some have smaller space. So that internal space serves as the depth of that box. So that is the third dimension, which this 3 stands for. So how deep is the depth to the center? How deep? What is the distance from the corner to the center of the box or the prism? A prism is like a triangle that is thick, that is 3-dimensional, or a sphere, or a ball. Now a ball is round, you understand, but now how thick is this thing? So that is what we are looking at. That is a 3-dimensional. So depending on what you are looking at, for example, in geography, if you are looking at the earth element, you could be looking at how high is the mountain. So if you are standing on the ground now, a mountain is in 3 dimension, and maybe you drew it on your computer. You have the image on your computer which you snapped, and you have it on your computer. At that point, you are going to be looking at, okay, what is the height of the mountain, or what is the depth of the iceberg? You understand? So the most common word used for this position of 3 is depth, but you can also use it as height. And for me, I choose to use it as table. Do you know why? Because we have row and column, and we know a table is made up of row and column. So we are having 3 tables, each having 2 rows and 3 columns. And all these 3 things coming together forms a database. Yes, a database is made up of tables, and these tables have rows and columns. So you can look at this now. For me, I'll look at this and say, okay, this is a database that contains 3 tables, and each of the table have 2 rows and 5 columns. So let's look at it. So this is our NumPy array. So now each table, you can see how I arranged it so that you can understand better. So this 2 is a table, forms a table. This 2 forms another table. This 2 forms another table. So these are the 3 tables. 1, 2, 3. Now let's look at how many rows does each table have. Don't forget we are having 2 rows. So this is row 1. That is row 1, row 2. So this is row 1 and this is row 2. Now, how many columns do we have? This is 5, right? So let's look at the column. This is column 1, 2, 3, 4, 5. So we're having 5 columns. So this is our database, or this is our NumPy array, which contains 3 depths, 2 rows, and 5 columns. So take note, in Python, numbering starts from 0. This point is very, very important so that you will know how you are going to reference what you are referencing. When you are counting, you start counting from 0. So here we have this table now is table 0, table 1, table 2. This is row 0, row 1, row 0, row 1, row 0, row 1. Then when we are looking at the column, this is column 0, 1, 2, 3, 4. So when you are referencing, take note of these numbers. Then we print our array. So here we are. So we are saying for array A, that is result A now, we are going to print out all elements in table 1 only. So if we want to print out all elements in table 1 only, now we are to reference each index. Now, this is an index, this is under index, and this is under index. So now we are dealing with only table 1 here. Take note, this is table 0 and this is table 1. Take note, this is table 0 and this is table 1. And the question says print out all elements in table 1. So elements we are printing out are elements on this table. Elements on this table. Please take notes. So now, how do we reference it? Follow me carefully. So we start from the table element. Take note. This is the table index here, these 3. So that is what we are going to be focused on now. So how do we reference this now? So this is how I reference. I said 1:2. Now take note. When you are indexing, when you put, for example, the meaning of this 1:2 means print all elements at index 1 and stop at index 1. Take note, when you are indexing, or if you are looping, for example, a for loop, if you have a for loop and you say, for example, for t in range 5, 6, you are trying to say, hey, start from index 5 and stop at index 5. Why? Because when you are dealing with for loop, it doesn't take into consideration the last number. That is, that's 6. It doesn't take into consideration that. So that applies here too. So it's going to start from index 1, which is table 1, and it will stop at table 1 because it will not take into cognizance 2. If, for example, we put the number 3 here, it's going to print out table 1 and table 2. So now let's look at it. Let's run the code and see if it's going to print out table 1 and table 2. So you can see this is our array here, the original array which I printed. That is the original one. Now this is our result here. So we have array A 08261. You can see it here, 08261 and 739027. That is table 1. And look at table 2, 451 and 80. You can see it. So it printed out table 1 and table 2. Let's go back. So if we are to change it now to 2, it's going to print out only table 1. So look at it now, table 1, 0826. Look at it, 0826. So somebody who might be wondering, oh, what is the importance of this? As I said earlier, machine learning deals with numbers, and because of that, we use the NumPy array very well. Now, I've already posted on the announcement page that in subsequent weeks, we'll be looking at deep learning. And when you talk about deep learning, you must use a three-dimensional array. If your data set is a one-dimensional data set, you must put that data set in a three-dimensional format. That is how deep learning models work. Example of deep learning models: RNN, convolutional neural network, CNN, and so many others. We have the LSTM, which is under the RNN, and so many other. We have the transformer and so on. So you can't use this deep learning without knowing how to manipulate your three-dimensional array. So this is a preamble to the deep learning tutorials that we'll be going into. So let's take this very serious and make sure we understand how this operates. So now look at the next one, B. Print out only elements in row 1 from all tables. What are we looking at here? Row. And where is our row index? Our row index is the third one, which is this. The second one. The first one is your depth index or table. The second one is your row index, and the third is your column index. Now the question says print out only elements in row 1 from all tables. So what they are expecting us to print out is all elements here, here, and here. These are the things that should be printed out. Remember, the indexing starts from 0. It starts from 0. So you're not printing out elements on this row. That is not row 1. That is row 0. This is row 1, row 1, row 1 for each individual table. So let's see how we are assessing each element in row 1 from all tables. So we're printing all the tables, so we don't need to put anything on the first index. So now we're looking at only one row, which is row 1. This is it. So we are indexing row 1. So we're saying row 1, 2. We didn't put any other thing. Take note. Row 1, 2. We're supposed to put another number here. Here, we're supposed to put another number. Let's say row 1 to row 2. But it's not necessary. Why? Because that is the last row. So a row 1 to what? On a normal day, if we have, for example, like 5 rows, once you put 1 to nothing, it's going to print out all rows from row 1 to the end, to row 5. But at this point, we're having just 2 rows, row 0 and row 1. So there's no other row after row 1. So even though you don't put any number here, it's still going to print out only row 1 because that is the last row that we have. So let's look at it printed this way. Okay, sorry, let me edit my code. Let me comment this out and uncomment this and rerun the code. Okay, here we are. So let's look at our results. 615, you can see it, that is for the first table. 739, that is for the second table. 802, that is for the third table. So let's do it the initial way I wrote the code. So let's remove this and run the code again, and let's see what it will give us. The same thing. 615, you can see it. 739, 802.